guys, Sal here with SS Multimedia. Today we're going to be talking about place-value relationships. Okay? So this is going to be our objective, explaining how digits relate to each other using their place values. Okay? So today there's only going to be two parts really, is how digits relate to each other and place values. Okay? And this one, I can't even explain because that's actually part of the lesson. So the only one I'm going to explain right now is digits, okay? And I'm sure you probably know what it is, but just in case, let's review. Okay? So say we have the number 27, okay? But we're only counting this number. Okay, so what do we call it? We can't say I want the first number because you could be referring the first one on the right or the first one on the left. So what are you going to be saying? I'm going to be saying I want the digit here. Okay, this is called, not this. Okay, so if we have these two numbers, 1, 3, 7, all three of those individual numbers, 7, they all come together to create 137, right? So each of those individual numbers are called digits. Okay, so 7 here, this number. If you split this apart, this one would be a digit, and this one would be a digit, right? So numbers 0 through 9 are digits, okay? So that's what a digit is, and now that we know and understand at least what most of our objective is, Alright guys, so today the main part of our lesson is going to be about how digits relate to each other and place values. Okay, so that is what our lesson is going to be about. Okay, and to explain place values and how digits relate to each other, I created a chart here. Okay, it's called place value chart to help explain what this means. Okay, so now let's say I'm writing the digit. This is some random number, okay? And on each of these lines, I'm going to write a digit. Okay, so let's write 2, 4, 8, 9, 7, 6, 3. There. Okay, so now if you read this, you would get 2,489,763. Okay, so now we have to explain, how do we know it's 2 million, right? Why couldn't it be 2 billion? Right? Or what does it mean? Like, why is this one there? Why couldn't this number be there? Right? Why aren't these two switched? Huh? Wouldn't make too much of a difference. That's where you're wrong. Okay, so this is what we're going to be explaining. So each of these is in its own place value. Okay, why is it called that? It's because, well, these lines here they all are a place, and they all have a value. Okay, so this is the ones place. Okay, this is the tens place, and this is the hundreds place. Okay, so now let's go through these. Why? Well, tens, obviously, because whether you write 710 or 298, right? This number always is part of the tens. You could always use tens blocks to define it. That's why I'm sure you've heard the term 10 blocks, which are these like strips, you know? They're like kind of like blocks, and they're used as a model, right? So those are because this is in the tens place. And then hundreds place is this number, right? Those two numbers there, those are the hundreds place, okay? And that same goes for the ones. The ones place, okay? And now after you really understand what these places are and memorize them, it's easy after that, right? Now you have thousands, okay, thousands, then you have 10,000s. I'm just going to write 10,000 like that because I don't want to write for too long. 10,000s, then there's 100,000s. I know I'm scribbling, but that you'll get what I'm saying. And then this is millions. Okay, so nobody knows what the infinite number is, right? What's the largest number? So people like, hey, you have a place chart. Why don't you tell me what the biggest number is? That's an interesting number, right? So somebody would say, hey, gajillion. Okay, so somebody would just say gajillion or zillion. any of those numbers, right? But the problem is there's always going to be, say you think it's zillion, okay? It's always going to be zillion and 1, right? Think about it. So that's why it's important to know the place value so you understand why, okay? So now let's figure this out. How do these numbers relate to each other? So I think you should understand what place values are, right? So now let's figure out how do these numbers relate to each other? Okay, so now this part works if we have two of the same numbers. So say we have 277. So let's write that down here. 277. Okay, so now if you use this chart here, so let's create another chart. 1, 2, 3, 277. You know this is in the ones place, tens place, and the hundreds place. Alright, so now let's work on that. How do these two numbers, so this part doesn't matter for this conversation, so let's put that away. Now, how do these two numbers relate to each other? Okay, so we have those two charts. This one is times 10. So if you do 7 times 10, 7 times 10, what do you get? You get 70, right? And this has the value of 70, okay? So I know you doesn't make sense because it's 7 and 7. So how does this one have more value than the other? It's the same digit, right? So that's where place value comes in. This place value is greater than this place value. If you think about it, not one digit in the ones place value is greater than the 10th place value. Okay? Even if you have a 19, right? And you think, okay, now it looks like this one, the 9 is greater than the 1. No, the 1 is greater than 9. Okay, so I know you've probably thought, okay, I'm never going to hear that 1 is greater than 9. But yes, for the purposes of this conversation, 1 is greater than 9. Okay, so how? Because it's in the tens place. Okay, and this is in the ones place. It could be 1,000,009, and still 1 would be greater than 9. Okay, but it would be a different story if the number was 901. Now, yes, the 9 is greater than the 1. Okay, so that's how the place value works. Because this 9, if we take away this 1, so let's subtract the 1, subtract 1, you just still get 900, right? So now you have 0, 0. That means, so if you take this number, right, and you just add a 0 to the next of it. So we have the value, we have 7, add a 0. If you add a 0 for all the places to come, that's the value. So this 7 has a value of 70, this 7 has a value of 7. Same way this 2, and you just fill in the next in zeros, this 2 has a value of 200. Okay? So I know you're thinking, okay, 2 cannot have a value of 200, but it can because of place values. Okay, so that's the point of this lesson. So now how do these relate to each other? Well, how do you get from 7 to 70? Right? There has to be some mathematical explanation. How do you get from 7 to 70? Right? They're the same number. That can't be a coincidence. It's not. 7 times 10 equals 70, right? That's what we did in the beginning. 7 times 10 equals 70. So to get from this 7 in the ones place to the 7 in the tens place, you have to times 10. So that is times 10. Now, if we're trying to get from here to there, what is the opposite of multiplication? So I want you to remember about the different operations. What is the opposite of multiplication? Take a moment to think. Okay, so I'm assuming you got it. The opposite is division. Okay? So that means to get from the 7 in the tens place to the 7 in the ones place, you have to divide it by 10. Okay? But that only works when there's two same numbers, right? So now let's say instead of 2,400,000, okay, 2,400,000, okay, instead of the 4 in the 100,000 place, put a 3 there. Okay? So now let's see, are there any other 3s? Yes, there is. Okay? So what is the difference between this 3 and this 3? Okay, so now it's obvious because now that we know about place value, this one holds a lot more value. If you fill in all the zeros, you get 300,000, and this one is just 3. Okay, so we know that. We want to know how much more, right? So now we're going to kind of use like a number line method. You're going to jump all these. So we have times 10, times 100, times 1,000, times 10,000, times 100,000. So 3 times 100,000 equals 3. So now if we do this, we get times 100,000. Okay? And if we're going this way, let's say instead we're going this way, it would be divided by 100,000. Okay, so those are how digits relate to each other. Okay, so believe it or not, that's actually the end of the lesson. So what do we do at the end of the lesson? Problem time. Okay, so today's problem time is going to be different than the ones we've done before. Today, you're not going to post your answers in the comment below. Okay, today's a different kind of problem time. Today, you're going to do it along with me. Problem time is actually kind of part of the lesson itself. Okay, so let's do this. So let's write a number here. Let's do 1,517. How does the 1 in the tens place relate to the 1 in the thousands place? That's the question. Okay? Let's do this. Let's write our place value chart here. We have 4 places, so 1, 2, 3, 4. Okay? Now let's figure it out. We have a 1 here, the 1 here. We don't care about the rest of the numbers. That's not part of this. Okay? And since this part is not there, that doesn't matter. Okay, at least for this conversation, this place does not matter. Okay? So now if you remember, we're going to make jumps. Times 10 times 100. Okay, so it looks like to get from here to there, times 100. Okay, now always remember to make the arrow pointing this way. Okay, so if we're trying to say we had 1, 0, 1, and we're trying to say that to get from this number to that, to get from this digit to that digit, you have to multiply by 100. You wouldn't draw an arrow like this, because that means, even if you're trying to say the right thing, that means to get from the digit in the hundreds place to the ones place, you have to multiply by 100, and that's wrong. You always have to make sure the arrow is facing the right direction. Okay? And now, say we want to do it the other way. Draw another arrow here. Divided by 100. Okay? So that's the answer for this one. Okay? Times 100. Okay? Now let's do one more. Okay, just to make sure I drilled it into your head. Let's do 7,834,270. Okay, so that's a big number. Let's solve it. How much does it take to get from the digit in the millions place to the digit in the ten place? Okay, so remember, the arrow now has to be facing this direction because we're trying to get from here to there. Okay, so let's get started. Let's draw our place value chart. 1, 2, 3. So 1, 2, 3, 4, 5, 6. That's how long it takes to get from there to there. 1, 2, 3, 4, 5, and 6. We have 7 and 7. Let's figure this out. Let's make the jumps. We have times 10, times 100, times 1,000, times 10,000, times 100,000. So the 7 in the tens place has to be multiplied by 100,000 to get to the 7 in the millions place. So what that means is, because this isn't just 7, this is 70. This holds the value of 70. That means that 70 times, okay, that was a bad place value. So let's do 70 times 100,000 equals 7 million. There you go. Okay. And just one more thing before I sign off. Always remember to put a comma after every 3 digits. Okay, so say we have this number 5, 4, 3, 8, 9, 2, 7, 8. Where do we put the commas, right? Because you have to put a comma. Where? You count every 3 digits. And after that, you put a comma. And always make sure you're doing it right to left. Okay, I know that will feel odd when you're doing it in the beginning. You'll get used to it. Right to left, right to left. Okay, so let's do 1, 2, 3, comma. 1, 2, 3, comma. 1, 2. So there's no 3, so we don't need to put a comma. So now that number is 54,389,278. Okay. All right, folks. Thank you for watching this video. Please like, share, and subscribe. Keep an eye out for the next videos to come.